Hey everybody, good to see you all today. Welcome to Cassandra Lunch 37. We've been doing this all for almost a year. Still, another 4 or 5 months will be a year. Not even. I think by the time we hit April and May, we're going to have a year of Cassandra lunches. So thanks for making that happen. I'm just going to give you guys a quick view of what we've covered so far. And you can find a lot of this stuff after at least Cassandra Lunch 10 on YouTube. Last week, we covered specialized data stores that are powered by Cassandra, like time series databases and graph databases, and even just full-on API document storage, et cetera, that are backed by Cassandra protocol. And today, what we're going to talk about is just basic data operations. Some of the simplest problems, people have no idea how to deal with it in Cassandra because they're new to it. And our presenter today is actually Arpan. Arpan has presented before on things like Spark and Cassandra, but that's what's on stage for today. So without, well, I do have to do the introductions because we're part of a larger community, so please bear with me. Yeah, there we go. SQL copy for data operations by Arpan. I am now your sole organizer because Akwi is transitioning to go back to school to get a PhD. He's going to be Dr. Ohieri. Looking now for definitely a co-organizer that can help put this on. Andrew's going to be helping in the background, and until we find somebody to help. Data Community DC is a large community. Beyond this group includes Data Science DC, statistical seminars, data wranglers DC, which we have a data engineers lunch every Monday, same time. What do we cover here? We covered the Cassandra protocol, which happens to be in different products nowadays, not just Cassandra or DataStax. It also happens to live in ScyllaDB, it lives in Yugabyte, it lives in Cosmos and managed key spaces for Cassandra from Amazon. All right, so at this point, we ask people who are new just to say hi, what brought them here, what they want to learn, and maybe if they could present something, what they would be great at presenting. So no pressure. If you don't want to, you don't have to. So I see Sujay Shankar. Do you want to say hi real quick? No? Okay. Calvin? He's muted.
Good afternoon. Can I be heard?
Yeah, I can hear you.
Yes, my name is Calvin Poindexter. I work in the federal government for the Countering Weapons of Mass Destruction Office, and I'm just doing some research on Cassandra. I saw that DC had this meetup locally, so just here to learn more about the platform. I've heard of it, but don't know much about Cassandra. So just doing some observation and market research.
Sure. Yeah, that's great. And there's a wealth of information on the YouTube where we've recorded previous sessions. So before you go today, after we wind down, let me point out specific videos that I would recommend to get like a broader understanding. Today, the topic is going to be fairly focused on some data operations.
Okay.
Because there's so much. There's just so much.
Right, so. Right. Okay, I'll stand by for that. Thank you.
Yep, cool. Excellent. Well, thanks for coming, Calvin. Group rules, if you have a question, just ask it. Be polite. You can also just ask a question on the chat. Of course, the speaker may have their own preference as to how they want to interact with you. Some people, they just want to see the question in the chat and they'll answer you. our company Anant is a partner and a sponsor for this group. We design, build, and manage platforms that are built on Cassandra, Spark, and Kafka. DataStax, which is one of the commercial vendors for Cassandra, they support us. Although these days it doesn't really cost much to support a Zoom Zoom account, but they used to pay for pizza and soda before. Hopefully, they'll continue to do that. I actually just chatted with the community dev relations leader this morning at DataStax, Cedric, and he said that we could potentially host Cassandra Lunch on the Fellowship of the Rings, which has about 9,000 people on it. I was like, whoa, well, let me think that over. So that'll be kind of cool. GW University is a partner with Data Community DC, and hence, because we're part of Data Community DC, we get venue space whenever they open up. Right now, it's a little dicey, as you can imagine. We have some local sponsors in Chicago and DC. We have organizational sponsors that support the nonprofit. And just as a plug, I meant to do this a couple of weeks ago, but Data Community DC is looking for volunteers in several capacity. So, if you're interested, or if you know a student that's looking to get really immersed into the data world, it's a great way to get exposed to a lot of different people, a lot of different groups and technologies. Announcements from the group. If you have a job that you're trying to hire for, if you're looking for a job, if you have a hackathon or class coming up, feel free to just unmute yourself and tell us what's going on. I don't see anybody. So if there are none, we'll just go to, there's a couple of topics coming up. So before I go to upcoming topics, every Wednesday we have this at noon. Every Monday we have, it's not always related to Cassandra, but it's data operations. And so if you go to Data Engineers Lunch, a lot of what we talk about and people present are applicable to Cassandra. And here are some topics that have bubbled up that we're going to try to find speakers for, or come up with content ourselves. And with that, I will hand it over to Arpan. I'm not sure if you can hear me, but you're muted and your video is muted as well. There we go.
Yeah, sorry, you cut out for a bit. I didn't know if it was me or you. But yeah, can everybody hear me?
Yep.
Yeah, I can hear you. Yeah, and I agree. It was a cut off. I couldn't hear anything at all, Rahul, as well.
Yeah, so I'll go ahead and share my screen. So as Rahul mentioned, sorry, just going to give it a sec. I live right next to a Air Force base, so sometimes have jets, I guess, coming home for lunch. So yeah, can everyone see my screen?
Yep.
Okay, cool. So as Rahul mentioned, we're going to be covering CQL copy, and then some basic data operations that we can do with CQL copy. Just sort of as a high-level introduction of what CQL copy is, it's a set of shell commands that import and export CSV or delimited text files. So if you're not using CSV, or if you're using like TSV, you can set your delimiters and still use the commands. But essentially there's two main commands, copy to and copy from. Copy to copies data from a table and puts it into a CSV file. And then copy from copies data from a CSV file and puts it into a table. A little bit more about copy to. So some of the setup of running a copy to command, it's a copy, and then you would insert your table name. And then if you have specific columns that you're trying to extract, so if you only want to extract a few different columns, you can do that. And we'll talk about that in the demo part because we do that. And then you would do copy to, and then you would designate a file name, whatever you want to name your CSV or TSV, whatever file name you want to say. And then you can have options, and we'll go over that in a second. And then you can append multiple options with an AND operator. If no columns are specified, all the columns will be copied to the CSV file. And then a subset of the columns to copy can be specified by adding a comma separated list, as mentioned. So if you only want to pull out 3 columns, you could just have that in a comma separated list after the table name. And then the file name, when you're setting to extract to, it should be a string literal with single quotes. And then that should have the path to the destination file. And we'll be using a Dockerized Apache Cassandra container, and we'll show you how to do everything within that container. There are some steps that require it doing local to the container, but we'll go over all of that, and all the steps are outlined if you want to replicate it yourself. And then you can also use special values like std out, so standard out without quotes, to print the CSV to std out. And then, as mentioned, there's a few different options that we could do with copy to. So these ones are exclusive to copy to. There are ones that are exclusive to copy from, and there are also ones that can be used for both, and we'll go over those. So with copy to, you could set max requests. You could set page size, page timeout, begin token, end token, so your token range to export, and then the max output size, and then encoding. So it defaults to UTF-8, but you can set it as needed. And then copy from, it's very similar to copy to in terms of how you set it to run the command. You would still say copy, and then the target table name that you're trying to put data into, columns. So if you have specific columns that you want to take from the CSV file and put into your Cassandra table, and then from your file name. So in our case, we're going to simulate how to mount when we'll also physically mount a file to the Docker container. And then we'll say with copy options, so just like copy to, and then you can have multiple options with the AND operator. And just like copy to, if no columns are specified, all of the columns will be used from the source CSV file and be put into the Cassandra table. So sometimes if your CSV table does not match, or sorry, your CSV file doesn't match your Cassandra table data model, it will throw errors, and then you can get those error messages in your Docker container for us specifically, but depending on how you have your setup, your error message location might be a little bit different. And then again, you can specify which subset of columns to import. And then the file name, same thing, should be a string literal and should point to the path of the file that you're using as the source. And then all the rows in the data set must contain the same number of fields and have the values in the primary key fields. The process verifies the primary key. So again, if it doesn't like something, it will throw an error, and it's all or nothing. So it won't partially import some data. So if it's atomic in that sense. So like if all of it doesn't work, then it'll just roll back. And then you can set headers. So again, like I mentioned, there are options that can be used both by copy to and copy from, and header is one of those, and we'll cover that in a second. But if you have your header false and no columns are specified, the fields will be imported in deterministic order. And then when columns are specified, those fields will be imported in that specified order. And then missing and empty fields would be set to null. And the source, so your CSV file, can't have more fields than the target table, as I mentioned, but it can have fewer fields. And then also, it's suggested that you don't import more than 2 million rows. So if you have a CSV file that's greater than 2 million rows, you would be more inclined to use the Cassandra bulk loader, and a link to that is available in the slide deck, which will be available when this YouTube video goes up, so likely tomorrow. Yeah, so the copy from exclusive options, it's a little bit.
You're gonna talk about DS bulk later, right? Not today, but in another talk, another day. Yeah. Okay, cool.
Yeah. Yeah, this is just a smaller scale demo today, but we'll cover DS bulk in a later discussion. So copy from options, you have ingest rate, max rows, skip rows, and skip columns. So you can use these to skip fields that you don't necessarily want, and skip rows. So if you don't say header equals true or header equals false, and you need to use skip rows, you could do that potentially, but that's what the header option's for. And then you could have max parse errors, max insert errors, error files. So you can say store the rows that did trigger errors in a certain, so you can see what are causing issues. Max batch size, min batch size, and can't see this last one. And then chunk size. Sorry, the the Zoom tab bar covers the very last line. So then these are the shared options. These options can be used for both copy to and copy from. So null val, header, as mentioned, decimal, SCP, so like separator, and then the 1000 separator, bool style. So if you have string literals or Boolean values, num processes, max attempts, report frequency, and I think the last one is output rate statistics. But yeah, so those are just a lot of different options that you could do. So you have a lot of functionality that you can use to do your data operations if you need to import and export. But the ones we'll be covering, we'll just be using header for the most part. But again, this is all just a simple demo, and you can expand on it because it's on a GitHub repo, it's public. So if you want to take it, modify it, do whatever you need to do, it's available. And it's available in the resources section. So it's also available on the blog post that's available on blog.anant.us. And all of these links will be available. So most of this stuff comes from Cassandra Apache docs, and then also DataStax docs. So if you're looking for something that I didn't necessarily cover, all of those links are available. So I'll pause here for the demo portion before we get to the demo portion to see if anyone has any questions. Otherwise, we can go ahead and move on.
Yeah, just a quick question, not to put you in a tough spot, although, you know, it's kind of fun to put people in a tough spot. So, you know, you use this CQL copy to, CQL copy from, and, you know, I know that Cassandra supports JSON data to represent, like when you do an insert statement with CQL, if there's a tuple or like a map or a list or a collection, you can put JSON in a string if it's escaped properly, and it actually will get materialized into that collection. Is it possible to put JSON in a line with the CSV?
I had tried it. I was running into some errors. It was probably a formatting issue on my part, but I believe you can, as long as it's, as you mentioned, escaped properly. So if it can read it and you use the correct option, so if you have delimiters and specific items set, I don't think there should be an issue to insert JSON in your, like a flat line JSON statement or a line in your CSV file. If you have more information about that, you can definitely expand on it.
Okay, cool. Yeah, I've seen it, like when I was doing the DataStax training, and I've actually delivered the DataStax training. There are some examples where they have, seems like they have JSON in there. But then again, you know, in the real world, we, after using CQL copy, like in a dev environment, we're generally not using it, right? We're like playing with DS bulk or Spark or something like that.
Yeah. I also played with a method to export as JSON. So you can, like, as you mentioned, you can select as JSON in a CQL statement. And then I played with some, I think it was awk, and it was exporting I think the example I was using was only exporting the first item, so like position 0, and it gave me back a local like JSON of my data. So I think you may be able to still import it in a similar sense, but if I can figure it out, I will update the blog and GitHub repo. But yeah, so if there are no more questions, I'll go ahead and move on with the demo. Okay. All right, so for the demo, we are going to be running a CQL file that will create 2 tables. And these 2 tables, there will be a source table and a destination table. So the source table will seed with 1,000 records, and the destination table will be empty. And then we're going to run a CQL copy 2 to export the data from the source table. So that way we'll have a CSV about 1,000 records. And then we'll show you how to export that out of Docker. And then we'll simulate, quote unquote, simulate some data transformations that I have already done for you. So on the GitHub repo, there's already a completed CSV that, say if we passed it to someone on the, like a business analyst or someone else on the data engineering team, and they handled editing CSV. Again, you could also do something, you can also edit the data with something like Spark. But we'll just say they used Google Sheets or Excel or something to manually make edits to the data in the way we needed it. And then we'll take that completed file and then put it back into our Docker instance and then use that for a copy from to put that into our destination table that's empty. I have all these commands written out on my second screen. I'm pulling them just from the GitHub repo, so you can just follow along. I'll put the link in the chat. Pull it up. And then we'll go ahead and get started. All right. Let me open up my terminal. So everything's going to be done within the terminal. All right, so I'm just going to go ahead and run a Git clone. I'm just going to clone that, and then following the instructions, we're just going to run a CQL CD into that. And then from here, we're going to run our Docker container. So in this, we're going to say Docker run. We're going to name it Cassandra, and then we're going to be using the volume flag from Docker to essentially take this entire directory, so the CQL copy directory that we get cloned, and put that into a directory called CQL copy in our Docker container. And then we're just going to use the latest Cassandra image. And then we're just going to give that a couple seconds to get running. But just to confirm that we have mounted our directory correctly, we are going to open a new tab, make sure we're still in the CQL copy directory, and we're going to Docker exec our Cassandra Docker container, and we're going to open the bash terminal. Oops. Whoops. All right. And then we're just going to do a quick list, and we should see our CQL copy directory. So if we just do a CQL copy. So again, like I mentioned, we have this completed simulated data transformed CSV that we're going to input into the empty table. And then we also have this CQL file, which I mentioned, which creates 2 tables and then also seeds the source table with 1,000 records. And then this is just the README from the GitHub. But when we get to the copy from, we're actually not going to use this file because, again, this is just already in the repo for you to have. But what's going to happen is we're going to, again, simulate those data transformations and then take it from our local directory and put it into the root directory and then use it from there. All right. So I am going to go now open our CQLSH terminal. So I'm just going to open a new tab. and I'm just going to run docker exec Cassandra CQL/sh. Now we're in our terminal, or CQL/sh terminal, and we're going to be using source. If you're not familiar with source, it's essentially a way we can use files to run CQL commands, and we're just going to go ahead and run that. So essentially what that does is, if you don't have the CQL file open on GitHub, I'll just pull it down real quick. So essentially what we're saying is we're creating a key space demo, simple replication, simple strategy replication factor of 1. We're going to say use demo. So that's the key space we just created. We're going to create one table, which is spacecraft journey catalog. It's going to have columns like spacecraft name, journey ID, start time, end time, is it active or not, summary of why that journey was made. And then the primary key is made up of a partition column of spacecraft name and a clustering column of journey ID, and it's clustered by journey ID ascending. So that's the source table. And then our destination table is duration by journey summary. And what we're going to do here is we're going to simulate data transformations where, say we want to take the summary of each journey and the journey ID of it, but instead of having a start time and end time, we want to have the duration in days. So if we want to use this data for like maybe just like a visual aid, or just for BI analysis, we can do this very quickly. So we can just create the table ahead of time, and then we can take specific columns using CQL copy 2. So we can take the summary, the journey ID, start time, and end time, and export those into a CSV. We hand it off to someone, or we do it ourselves, and then they calculate the duration in days by using a date difference function to get start time and end time, so the difference in days between those. And say if there's some garbage data in there that we need to clean up, we can do that as well. And essentially take that new CSV, which we have, as mentioned in the CQL copy repo, and then take that, import it into our Docker container, and then use CQL copy from, and then use that to put it back into our duration by journey summary table. So again, like I mentioned, we're inserting into the source table, so spacecraft journey catalog, 1,000 records. But again, running this source command does it for you, so you don't have to have a bulky CQL/sh terminal. So I'm moving this back up just so I can see it at the same time. So now that we've done that, we're just going to use demo, and then we're just going to do a show, sorry, my SQL is coming out, describe tables. And we have our two tables. So if we just do select all from spacecraft journey catalog, we should get back, oh, that's not what I want. I want a select count. All right, so our 1,000 records are there. So now what we can do is run our copy statement. So as mentioned before, we're only going to take a subset of columns from the source table. So if we just describe this table, as mentioned, we have 1, 2, 3, 4, 5, 6 different columns. But what we're doing here is we're saying copy spacecraft journey catalog, only take the column summary, the columns summary, journey ID, end, and start. And then as we mentioned before, remember to, and then single quotes, the file destination, which is when you use in the Docker container, if you use .. it puts it at the root. So we would name the file spacecraft journey catalog.csv, and with header true. So we're saying make the first row the header of the column names. And so we can see the analytics of it after. So we can say it started the copy, it picked it up correctly. So it said with columns, summary, journey ID, end, and start. It processed 1,000 rows. It gave us a process rate. And then it said our rows were exported to one file in 7/5 of a, or not 7/5, but 0.75 of a second. So now if we go back to our root directory that's running bash, and we just run a list, we see our spacecraft journey catalog CSV that we just created using copy 2. Now if I just run a cat on it, and we'll just see all the data in there. But if we go to the first row, as we mentioned, we used header true. We have our summary, journey ID, and start. So we were able to quickly take the data we wanted out of one table using CQL copy 2. So now what we can do is export it. So if we are handing it off to someone or we need to make data transformations on it, we'll show you how to do that. So going back to the first terminal, which is just in our CQL copy directory, it's not running Docker, like it's not in a bash terminal or CQL sh terminal. It's just our root or our CQL copy directory. To export and import CSVs, we'll need the Docker ID. So you can just run Docker PS and we can copy this container ID. But first what we'll do is we'll use Docker CP, and then this container ID is templated. So we'll just copy and paste it into where it says container ID. And then we're saying, put it at the root of the directory. So it would be put in the root directory of CQL copy. And we're taking this file, or sorry. I got confused for a second. We're saying Docker copy the container. And then so this first slash is saying the root of the directory. So we're saying take this file. And then with this period, we're saying put it in the root of the CQL copy directory in our local CQL copy. So from our Docker container, from the root, take that summary journey catalog CSV or spacecraft journey catalog CSV, and then put that in the root of our local CQL copy. So if I run this, and then I'm just going to open, if it shows up, CQL copy, and it's now here, right? Spacecraft journey catalog, and that's what we said, spacecraft journey catalog CSV, and we just exported it. So if I open this up real quick, so we see the CSV file. So we have our summary, we have our journey ID, we have the end time and start time. So say if we give this CSV to someone and say, here, make our data operation. So essentially take the end time and start time and calculate the date difference, and then give us that back. So we have done that for you. So that's this duration by journey summary CSV. So if I open it up, so summary, journey ID, but now we don't have those start and end time columns. Now we just have the duration and days. So this is all we need for the destination table that's currently empty. So using this destination CSV file, we'll need to import it in a very similar way. Instead of saying from our Docker container, put it in our local directory, we're saying from our local directory, put it in our Docker container. So the command is very similar. So it's Docker CP again, and then the CSV file is obviously different, but it's Docker CP duration by journey summary.csv. So that's our new transformed data. And then we're saying in the Docker container, put it at the root. So I'm just going to paste in the container ID and run it. So now if I go to the bash and I run list, we now have our duration by journey summary CSV. So if I just run a cat on it, if we go up, summary, journey ID, duration, and days. So like I mentioned, technically we already have this CSV in it, but for demo purposes, we're showing you how to do the whole process. Because remember how we imported the CQL copy at the very beginning. So when we ran our Docker container, we said -v, and then we put the whole directory on it. So if I still go into CQL copy and then I run a list there, so we still have this version of it, or this copy of it, but just for demo purposes, we're showing you how to do it after the fact, and how, if you did not have it in the original directory, this is how you would do it. But essentially that's it. So now we can move on to running CQL copy from. And to do this, it's very similar to the CQL copy 2. So we're saying copy from our duration, or sorry, copy the duration by journey summary table. with the columns summary, journey ID, duration in days, from, again, remember, single quotes for the file, dot, remember, we're only one from the root, and then this is the file we just imported with Docker CP, and we're saying with header true, so it recognizes that the first row is just the column names, and so it'll ignore it. So now, when it runs that, it says, process 1,000 rows, it gives us the rate and the average rate, and then it says 1,000 rows imported in about half a second. So now what we can do is go to just a select count, and we should now see 1,000 records in the duration by journey summary. So if I just do a select all from duration where summary equals says crew rotation. So this is the new data. Sorry, let me do it from the old data first. So the source data. So it would be spacecraft journey catalog, where ISS equals, or sorry, where summary equals, nope. That will actually fail because if we looked at the data model of the first table, it's actually spacecraft name is the partition column. So, all right, so now it's back. So we'll just do a select all from duration by journey summary, where summary equals SS crew rotation. So now we have the summary, which is, so this specific partition, the journey IDs associated with them. Again, remember it's a clustering column when we created it in the CQL file. And now we have calculated duration in days. So if we match these up, which we're with which are in our source table, we now have duration calculations versus just having a start time and end time. So that's just a very simple and fast way of just doing basic CQL copy data operations. So we covered how to export data from a table, how to, assuming we simulated data transformations, just using an Excel or Google Sheet. And then we also showed you how to take that new data and put it into a new table using CQL copy from. Again, this is just a very basic demo. The record amount was only about 1,000 records, but when we cover something like DSC bulk loader, we might cover something with a lot more data in it. But yeah, that will wrap up the demo portion.
Yeah, Arfin, great. I was going to say, as people ask questions, maybe bring this page up to show what else, is going to be coming up, because this is just one of the like eight different ways that we're going to be covering over the upcoming weeks and months. Yeah, there we go.
So as Rahul mentioned, these are all the different types of data operations we could do with Apache Cassandra. As you mentioned earlier, I covered Apache Spark and Cassandra, and we did a very similar, well, not very similar, but we did using local Spark in a Apache Cassandra Docker container. We showed you how you can use data manipulations and data transformations using Spark, and all of the information there and a demo is available on the blog itself. However, if you want to watch a live edit of the demo, you can check out the YouTube video itself on youtube.com/AnantCorp, and it's Cassandra Lunch number 30.
35 or
34.
34, 35, yeah.
But yeah, so in the tank, we have a bunch of different topics that we have. So we just covered CQL copy today. And as Rahul mentioned, we'll cover like table loaders and then DSC bulk with sed and awk. We'll cover sed in next Mondays. So this upcoming Mondays, data engineering lunch. we'll just give a high overview. I'll also be speaking there as well, so it'll just be a high level overview of SED, and then just a simple basic demo of how you can learn how to use SED and a couple different options and flags you can use. So if you're not familiar with SED, it's like a stream editor, so you can make data operation changes and data engineering changes to files, and then you can visualize it. If you want to save it, just copy it to a new file. But we'll cover that in next Monday's data engineering lunch. But Rahul, do you want to talk about other topics we're going to cover?
Well, let's see if anybody has questions. I wanted to expand on your presentation a little bit, both as a kind of like as a gap between what you covered and what we're going to be covering in the future. But are there any questions for Arpan? Awesome. Yeah, so I just wanted to add that CQL copy is built into Cassandra, Apache Cassandra. The rest of these, well, except for SS table loader, the rest of these methods are extra to Apache Cassandra, meaning Apache Spark, you basically have to bring Apache Spark either as part of like a bundle like DataStax, where you have to install Apache Spark or use Elastic MapReduce or whatever, right? And a lot of these are related to Spark. In fact, except for DS Bulk, almost all of them involve Spark. And I'll get to that in a second. DS Bulk recently, I don't know if it's open source, but it used to be just a part of DataStax, but they've kind of like made it work with regular Cassandra as well. I think that tool is essentially the successor to CQL copy, because it can do basically everything CQL copy can do, plus it can do JSON natively, right? You can do JSON import, JSON export. You can do, I don't know if it does JSON to CSV and CSV to JSON, but there are different tools that do that. But the cool thing about DS Bulk is that it can work at scale, because what it does, it connects to different nodes in a cluster. And that's the ultimate difference between all of these other methods and CQL copy, is that CQL copy is running on that one node. So like right now, Arpan has one node, so it's going to work fine. But let's say you have 1,000 nodes, and there are clusters with 1,000 nodes, and the data is distributed across the 1,000 nodes, and you do a CQL copy. Well, even if you do it, you have to figure out, well, how am I going to query that data, right? So normally, if you're not using a secondary index, if you don't have a where clause, it's literally going to have to scan all 1,000 nodes to get that data to your one node where you're running CQL copy, right? And so that's why they say don't do more than 2 million rows, because what it has to do, it has to gather all the data from all those different nodes, bring it to that one node, and then it's going to save it to your disk, and vice versa, right? And it's not the most efficient from a distributed perspective. I think that if you're under 10 nodes, 20 nodes, 30 nodes, you can use CQL copy as long as your query is not going to bring down the cluster, right? And these are problems that people have when they have big clusters. They're not really problems when people have like 6 nodes. It's like whatever. You don't even notice it. You won't even notice a problem with 6 nodes, because 2 million rows, even 10 million rows, what it's going to do is it's going to eat up a lot of memory because it has to bring it all in. But eventually it's going to handle it if you have enough memory. But yeah, looking forward to the upcoming topics. I think the DS Bulk is going to be really exciting because it has so many different flags, like source, destination, and I think it's extendable, so you can add other formats. But right now, I think it supports CSV and JSON. Maybe, no, I don't think it supports Parquet, but it definitely supports JSON and CSV. Cool. Awesome. If you could back, thank you. Let me bring up the deck again so we can close out our presentation. So thanks everybody for joining. If there are no questions, we can call it a day. Actually, Okay, Calvin, if you just stay on for a second, I sent you some links, but I wanted to show you a few things. But we can stop the recording right now. Okay, Director?